Welcome to the Demonstrating Implementation Excellence stream of SNOMED CT Expo 2022. My name is Linda Bird and I am the Implementation Support Lead at SNOMED International. I will be moderating today's session. All questions will be answered at the conclusion of the presentation. Online attendees, please use the Q&A box to type in your questions. And on-site attendees, please use the microphones provided. I'm now very pleased to introduce François Macary from FAST, who will be presenting Making Drug Therapeutic Indications and Contraindications Actionable. François, please proceed.
Thank you very much, Linda, for inviting me here. I'm very happy to be in this very lovely place with the gardens across the various rooms. So I'm working for FAST company based in France, and I will show you how we have combined a set of interoperability standards, including reference terminologies, to convert therapeutic indications and contraindications of drugs from a textual format to a machine-readable format that can be used for reasoning. So where should I point the device? Is it good? Okay. Sorry about that. We haven't tested the device. So I will start by stating the scope and goal of this project. And then I will show the various models and standards that we have put together to reach this goal. And I'll talk about the method that we have followed for this transformation from textual format to machine-readable format. And then I will illustrate the overall process, walking you through a simple example. And I will conclude this presentation with the next steps. So please, next slide. So FAST is distributing a catalog of drugs authorized to the French market. This catalog identifies and describes drugs with their pharmacological characteristics, and we distribute this catalog to hospitals in France in a standardized manner so as to support semantic interoperability of clinical workflows. And the goal of this project is to make this catalog even smarter by adding the clinical characteristics of drugs found in their product summaries. And what's happening there? So, yeah. So adding the clinical characteristics of drugs in this catalog and making all this available to consuming application, in particular clinical decision support services, in a standardized manner, so relying on interoperability standards, so that any system aware of these standards be able to use the content of the catalog for its own reasoning when it is involved in clinical workflows using drugs, such as prescribing, dispensing, or administering. Next, please. So what models did we have to assemble, and what are the underneath standards? Let's have a look at these. So starting with the models, please. And as demonstrated by this paper from Alan Rector, quoted here, we need to assemble three models. The information model, which provides the data structures used to convey the information in the exchanges and to store the information in the patient record, and as well as in the catalog. Then we need also the concept model, which provides all the meaning of this, the information conveyed, and the inference model provides the knowledge and the rules which enable to draw conclusions out of the data which have been received and stored. So for each of these models, we have picked a set of interoperability standards to make the content available through these standards. So next slide, please. And starting with the information model, we have selected the HL7 FHIR standard, which provides resources which provides 5 resources, both to represent the data in the patient record and to represent the content of the catalog. So to represent the knowledge about the drugs with their pharmacological properties and clinical properties. So the picture is a bit small now, but I think it will zoom up shortly. So this is it for the information model. For the concept model, the core terminology is SNOMED CT. And alongside SNOMED CT, we need also LOINC to provide diagnostic observations, quantitative observations, or physiological quantitative observations. And the EDQM standard and ISO IDMP standard are also useful to bridge clinical workflows using drugs towards regulatory workflows using the same drugs. So these standards are embedded in the catalog as well. And for the inference model, we have selected a very recent standard produced by HL7, which is clinical quality language, CQL. So these are the standards that we have selected, and now we will focus on each part. So focusing on the information model, you see here all the resources which are needed to convey the patient clinical context when you are prescribing or dispensing a drug to a patient on the left side of the picture. And on the right side, you see the resources that we have used to represent the drug themselves. So the core resources, medication knowledge, and the clinical characteristics of the drugs are conveyed by the clinical use definition resource. Next slide. So when you put in play the inference model, it selects the reasoning rules from the catalog, knowing which drug is being prescribed. And with these reasoning rules, it will then fetch the data, which probably have been provided alongside the prescription within the resources needed to check the criteria of the indication or the contraindication. And then it applies its reasoning to this data and then draws its conclusion. The concept model is really centered on SNOMED CT. So all the blue boxes here represent SNOMED CT concepts. The orange box represents LOINC. And so the starting concept is the administration of drug of medicament. And this is because both a contraindication or an indication always talk about administering a drug to a patient in a specific situation. So this explains why we take this concept as starting point. So it stands in the procedure hierarchy of SNOMED CT. And if you look at the concept model of the sub-branch of the procedure hierarchy, we have discovered a fair number of attributes which are very meaningful and appropriate to represent the various criteria that we find in the text of a therapeutic indication or contraindications. For instance, what is the intent of a treatment? Is it curative? Is it preventive? What is the category of subject? Is it are we talking about a contraindication for a pregnant woman or for a newborn, for instance? What is the route of administration? And the has focus attribute leads us to describe the disorder or the procedure which is targeted by the treatment. So then it will be more concepts taken from SNOMED CT there. And also the method of administration, is it infusion or injection? And so, as I had said, we need LOINC to convey quantitative observations, like calcium level, for instance. And we also need a couple of process variables which cannot be supported by a concept model. One is the maximum duration of the treatment, which may be mentioned in the text. And the other one is relationships towards another treatment. So this treatment is indicated as a replacement for this other treatment, for instance. Next, please. So how the inference model uses this. So we have laid out the concept, and then the inference model, one click, brings the logic, articulation, and one more click, please, with ORs and 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 minus operators, and a certain level of nesting, as much as what is needed, given the complexity of the conditions expressed in the text. And having done that, the inference model asks the question, is the administration of this drug indicated or contraindicated? One more click. In the situation represented on the right, and it will check the patient context data against this situation. So I will now talk about the method that we have followed to build this transformation. So we have followed an article which is quoted here, and which identifies 4 successive levels that the indication will be taken through, from narrative, which is a textual, to semi-structured, where you have split the text into logical blocks, meaningful blocks, and with a logical articulation between them. And one step further brings the structure level, where we convert the content to the standards that we have selected. And the last step is making all that executable. So focusing with a little more detail on this. So we have taken a method of 3 steps. The first step is splitting the narrative into logically articulated proposition. We'll see all that in an example afterwards. And so this takes the indication to level 2. Then second step is the logical and semantic normalization, which constructs a Boolean logic tree representing the logic of the indication, for instance, and which selects all the concepts which are needed to convey the meaning of this. And the last step is the formalization, so the conversion into standards. So both the FHIR standard and the CQL standard for the reasoning part. And with the last bit, which is the conversion from CQL to expression logical model, ELM, but this is achieved by automated tools which are available in the ecosystem. Next slide. So now I will walk you through the overall process from the text to execution, looking at a single example, which appears on top. So it's an indication for alpha-calcidol, and it's for the curative treatment of renal osteodystrophy, backed by evidence which can be radiological or biological. For biological, for instance, we are looking at the alkaline phosphatase and the calcium level in the patient. And all this being indicated when there are comorbidities, one of which can be renal insufficiency, backed again by some biological evidence, and the other one being hemodialysis. So the first step splits the text into two blocks, one which isolates the intent of the treatment, curative here, and the other one which focuses on the target of the treatment, so the renal osteodystrophy, and there you see the logic starting to being expressed, which puts together the evidences and the comorbidities with logical ands and ors. Next step, which is the logical and semantic normalization, builds a logic tree and selecting all the concepts which are needed. So for the second block, which is the target of the treatment, so the focal concept is renal osteodystrophy, and then we have the left branch of the tree, which deals with the evidences that will have to be checked, so which can be either radiological or biological, with serum alkaline phosphatase and calcium level in serum compared to thresholds. Then the right branch of the tree will check the comorbidities. So we may have one of the two, hemodialysis, so the patient undergoing hemodialysis, or a patient being suffering from renal insufficiency. And in that case, backed by the renal clearance creatinine. Next, please. Next slide. Yeah. So last step is the formalization into the standards. So we have in the catalog, we use the FHIR resources. So I didn't put all of them. I put the main ones. So medication knowledge, which is a main resource to describe the medication. And the CQL expressions, which convert all the tree that we just saw as expressions in CQL, in a CQL library, which will then be loaded into a FHIR resource library referenced by medication knowledge. Next. Yeah. And so now we are at execution time. And now we have a device that works. Thank you. And so on the right, we have the patient record, which is hopefully provided to a clinical decision support service. For instance, when prescribing the medication, so the prescription is represented by the medication request resource. And then you have all the other resource, condition, diagnostic reports, observations, which convey all the data that stand in the patient record, against which it doesn't work. So please do it for me. One click, yeah. So the reasoner, having picked the drug from the medication request resource, selects all the indications and contraindications that apply to this drug. And having done that, he will check whether the targeted conditions are there or not, whether the evidences that have to back these conditions are present or not, and which comorbidities are there. And having done all this check, the reasoner can draw his conclusion and report back this conclusion to the client application. And the conclusion will look like this treatment is recommended because it is applicable by this indication, for instance, or it is contraindicated by this contraindication. So here is just a snapshot of the rules that we have applied for the step 3 of the process. So for the transformation of the content of the indication as CQL expression. So I won't go through all the details, but for instance, if you look for a suspected allergic disposition at the bottom, the CQL will know that it has to look for an allergy intolerance resource with a verification status of presumed. Likewise, if you look for an upcoming procedure, the treatment is for an upcoming procedure, then the CQL will look for a service request code with status of active. So next slide, please. And so I'm reaching my conclusion, which represent our next steps in this project. So our catalog is dealing with more than 13,000 real clinical drugs for the French market, and more than 7,000 indications and a little less than 4,000 contraindications. Each of these may apply to more than one drug, of course. And so where we are now is that we want to automate the process of the last step, step 3, to produce the CQL expressions. So this is what we are doing now, and we will have news from that at the end of this year, starting on the contraindication side, and then we'll continue with indication. So with that, I thank you all for attending this, and I'm open to questions.
Thank you very much, François. François will now take questions. And as a reminder, if you're in the room, please use the microphone to ask your question. Does anyone have any questions? I'm not sure if there's a walking microphone, but oh, there is. Wonderful.
I have a question, but I've got a loud voice.
Oh, but for the people online, yes.
Thank you. That was a really interesting presentation. I was interested in the level of structured content to start with, and how you transformed that into the variables. Was that using natural language processing, or how did you start the process?
So we have a team at FAST which does this work. So we have built in a tool to do that. But most of the coding process and the identification of the various proposition of indication is done manually. I must confess. One thing that I forgot to mention about the selection of the concepts is that each SNOMED CT concept which is picked up is transformed into a value set of the concept itself together with all its descendants, so that the reasoner has a chance to capture the information irrespective of the level of granularity that the clinician has selected in his record.
Thank you.
And we'll take one question online. There's a question from Philippe, which is, how fast does this work? I'm not sure if this is a play on words, but how fast does this work?
Yeah, we start with an F, I guess. So we have taken a year to code all the indications and contraindications, and this work is done now. We had a team of at the beginning of 4 people coding, so physicians doing that work with our tool. And so now we are in the industrialization process. So if the question is about how long does it take to bring the system ready for clinical decisions system support, I would say it will be 2 years altogether.
Okay, wonderful. One last question. And then...
François, thank you for an excellent presentation. On, I think, slide 9, you were one of your focal concepts was administration of medicine, and you have a relationship to direct substance, which is what exists at the moment in the concept model. Have you considered whether that is the right relationship, and is that working for your inferences, or should it actually go to a medication concept rather than a substance concept?
Thank you for the question, Julie. So actually the direct substance attribute in the concept model of a procedure hierarchy has a range which encompasses both substances and products, medicinal products. So, and we are using medicinal products for values of this attribute. And this is legit with the machine readable concept model.
Thank you.
And one last online question. How do you code the side effect, as it may be different per clinical drug?
Sorry, I didn't understand the question.
The question is how to code the side effect, as it may be different for different clinical drugs.
Yeah. Thank you. Yeah, so the clinical properties of a medication in a summary are not only indications and contraindications, but then you have interactions, side effects, warnings. And so we plan to follow the same path for addressing each of these chapters of summary. But we just started with indications and contraindications. So these will be later steps in the project. But yeah, the plan is to follow the same path, and in the FHIR standard, the clinical use definition resource has been designed exactly for this purpose. So it is able to represent either a contraindication or a side effect, an adverse event, and so on.
Okay, wonderful. With that, we will conclude the session. Thank you very much, François. Online delegates, you can join another session through the event lobby, and on-site delegates, if you're playing our event game, please scan your QR code at the door to capture your attendance. Thanks very much, everyone.